So performing advanced calculations. There will be 3 slides. We will discuss performing advanced calculations through DAX, through Power Query and the advanced editor, and then also through tabular editor. Now we can do all of the things that we typically would do from a regular coding standpoint. So we can handle blanks, we can handle errors, and we can perform iterations. Now any column data type in DAX can have a blank value. This is the value assigned to a column when the data source contains a null value. Like, for example, in the example, we want to check whether a measure is blank, and then we want to assign the property is blank, so a text property, to that value. We can also handle errors by using the if-error function. So, for example, in our, let's say, data is inputted manually, if someone would state like a 0 as unit price, then we of course would have an error when we just keep the divide like this. So just to be sure, we put a if error there, and then it will catch that error and return a blank value. We can also create virtual relationships. So DAX calculations can leverage relationships present in the data model, but you can obtain the same result without physical relationships, so not connecting any tables, but using DAX functions. Typically do it using a filter function within a calculate, or an important function is the treat as. So we're treating something as it would be the same. For more information, check out the article in the references, but also definitely the documentation pages from Microsoft. So treat as quite an important function. Working with iterators, so sum x, average x, those are iterator functions, and we will see that if we use a regular sum function, that the total value is not always what we expect, and then we would require a sum x function to have the total amount displayed correctly. Let's also look at some examples of performing advanced calculations in Power Query. Through Power Query, we can use the ribbon and just create our applied steps that way. What we typically use a lot is a custom column function, where we want to perform all kinds of calculations that we wouldn't do using a calculated column. Using the advanced editor is of course another way of building your queries, stating your parameters and so on. And we've also included an example here. So there are some things that you have to keep in mind when you're working in the advanced editor, like the step names that must be unique. Also the let and the in statement. So the in always has, or typically has, the latest step name displayed. So it has to return all of the rest before it can enter that step. And then typically each step results in a table, but that's not always the case. And we see an example here of what how working with a parameter looks like. I think one of the things that they also state in the exam overview is actually calling a parameter in the advanced editor, so make sure you also research that topic. You can also perform advanced calculations through tabular editor using calculation groups. The use case for calculation groups is not having to rewrite a lot of measures that contain the same functions, but of course different data. For example, we might want to create a month-to-date, year-to-date, a quarter-to-date of, let's say, net sales, total wages, net, I don't know, like all these different financial data. Now, we would have to create a different measure for every single one of those columns. Calculation groups avoids us in having to do that. We can just specify the calculation that is required once, and then we can use it on the selected measures or columns that we created. Now, how do we do this in practice? We open up Tabular Editor, we select Create New, Calculation Group, and then New Calculation Item, and then we list the required calculations under that folder, let's say. And so here the month to date we specify the function, so a calculate function, but instead of really just selecting the required column, we state the selected measure function. So this will allow us to specify a measure later on. If you want to see how this works in practice, definitely check out the video of GynaCube in the reference list below. But it's just important that you know how you should use calculation groups and why this might be relevant to add in your model. Let's move on to the next item. That's the second already. That's Composite Models. Now, Composite Models. This is somewhat of a concept that's a bit more advanced. We also don't go really into too much of the actual implications of this change. Yeah? It's not that recent of a change, but it was quite a big, important change for Power BI. So previously in Power BI Desktop, when you used a direct query in the report, no other data connections, whether direct query or import, were allowed for that report. Now with Composite Models, that restriction is effectively removed. A report can now seamlessly include data connections from more than one direct query or combine import data with direct query. This change actually consists of three related features. So you once have, for one, have the composite model, then you also have the many-to-many relationships, and then you have the storage mode implication. So you can now specify which visuals query backend data sources, and this feature helps improve performance and reduce backend load. So for example, you can get your data from an enterprise data warehouse, combine this data using a direct query connection to a SQL server, and then also using import mode to get data from a flat file, for example. Let's actually take a closer look at the implications for the storage mode. The storage mode is displayed here with an example. So we have a couple of tables. We have sales, survey response, date, customer, geography. And we have some storage mode associated with that table. Now we see that setting these storage mode properties results in the following behaviors, assuming that the sales table has significant data volume. Power BI Desktop caches dimension tables, data, customer, and geography. So load times of initial reports are fast when they retrieve slicer values to display. Power BI doesn't cache the sales table. By not caching this table, Power BI Desktop provides the following results. Data refresh times are improved and memory consumption is reduced. Report queries that are based on the sales table run in direct query mode. These queries might take longer, but they are closer to real time because no caching latency is introduced. And report queries that are based on the survey response table are returned from the in-memory cache and are therefore relatively fast. So you see how it combines the two actually when they just need to, let's say, slice some dimension tables, it will use that import connection. If it does need some results from the sales table, it will also use that direct query. So this is really the example of having that dual storage mode and using that that composite model basically. We also have a great video on GynaCube that really goes into detail a bit more, but for the exam it's sufficient to know like what is a composite model, what is the impact on storage mode, and so on. There are some implications, some models where it's not you're not able to combine different data sources, and they are listed below. When we're discussing composite models, we also have to discuss user-defined aggregations. So what is this? Well, often it doesn't make sense to really have that direct query connection to the entire database, but instead you might want to work with an aggregation of that data. This will of course allow for faster querying and of course improve the user experience. There are some limitations, some validations that need to happen, but most important for us to understand is how do we configure these aggregations. So you right click on that table property and then you select manage aggregations, and then you have some properties that you have to respect. So you have the summarization property, for example, group by sum, the detail table, and then the detail column that you are trying to aggregate. What we can also do is after doing that or performing that aggregation, we can change the storage mode of that table to import mode. So in this case, the queries will of course be a lot faster when the data is imported in this way. So this is an option that we can take a look at. On the next slide, there's actually an example of what this looks like in practice. So you have the pre-optimization where you just have the sales through a direct query connection, and then on the right you have this sales aggregation table that these other columns are referencing. So in this case, sales is a very memory intensive table, so direct query is used, and then we're actually using an aggregate of that table to improve the model as a whole. As I said before, there are some limitations, some validations that occur when you open up the Manage Aggregations dialog, and these are listed here, but it's just for you to read and go through this in a second. We discussed already the most important things, so let's actually head over to the next section, which is denormalization. So our final topic is denormalization. So what is it? Well, normalizing a database involves removing redundancy, so only a single copy exists of each piece of information. Yeah? This is what we typically do in a star schema. So we have our ID columns in our facts table. We don't have any duplicate data there. This is all linked through our dimension tables, all perfect. Now, denormalization doesn't mean that we're reversing this, no. It's a technique that is performed on the normalized data. Denormalization is the process of adding pre-computed redundant data to an otherwise normalized relational database to improve read performance of the database. So we'll focus on the why here. So if we update the data at one place, there will be no chance of the duplication of data. But if the number of tables is very large, we have to spend a lot of time performing joins on those tables. So with the help of denormalization, duplicated data is considered okay, and some efforts to perform fewer joins with the efficiency advantages that it brings. So having redundant data can improve the performance in specific ways of database searches for a particular item. Whether this will improve performance or not is something that you should monitor yourself and see whether this is the case for your specific use case. Monitoring this, we will typically use Tabular Editor for this or another service. Tabular Editor or also DAX Studio, actually. Now on our final slide, we actually some advantages and disadvantages. Well, the advantages are, of course, the minimizing the joins, reducing number of tables, queries can be simpler, but of course the disadvantages, well, we're going against the principle of the star schema, so it may be a bit slower if we don't do it in the most efficient way. We might also be inconsistent throughout our approach. It can also increase the size of relations, and it can make code harder to write. We know that this is a lot of information to handle. We're also at the end of this section. These are some topics that are a bit more advanced but shouldn't really be studied in detail. It's just something that you should know when you come into contact with very large tables, that these things can help you increase performance and increase the user experience.